Hello everyone, now let's talk about the homework 3 problem number 1. The problem number 1 gave us that the probability of x equals to k equals to b times k times p to the power k minus 1, and k equals to 1 to the infinite, and p larger than 0 and smaller than 1. And first we need to find b so that the probability of x equal to k represents a probability mass function. First, from the definition of the probability mass function, we know that the sum of the probability x equals to k from k equals to 1 to k equals to infinite, the sum of this should be 1, which means k equals to 1 to the infinite should be 1, right? This should be 1. So we need to find out this part. We need to figure out what this part is. First, let's see that we know that k equals to 0 to infinite and the p to the power of k, this equals to 1 plus p to the power of 2 plus this equal to 1 over 1 minus p. And then we can differentiating both sides of this function. No, this equation. Yes, we can differentiate to both sides of this equation. We get that equals to 1 minus p to the power of 2, 1. So we can see this that this one times b, right? Is 1 times b. b times k equal to 0 to the infinite, k times p to the power k minus 1. This equals to this. It's exactly the probability x equal to k equal to this. So this equal to 1 over 1 minus p to the power of 2. So this equals to this, and it should be 1. So we figure out that, I'm sorry, here is b. So now we can figure out that b equals to 1 minus p to the power of 2. So now we get b. I'm sorry. Problem B. Problem B told us that we need to find the mean EX. From the definition of the mean, we get that EX equals to k equals 0 to infinite, k times p which this probability equals to probability x equals to k. So this equals to now we need to figure out what this is, because we just know what b is. So after we find out what the sum of k equals 0 to infinite, the sum of k to the power of 2 times p to the power of k minus 1 is, then we can find out what this function is. So we can use the method we show in the first question, that since we know that k equals to 0 to infinite, k times p to the power of k minus 1 is equals to 1 minus p to the power of 2 and we can rewrite this to like k equals to 0 to the infinite, k times p to the power of k equals to this. So we just differentiating the both sides of this equation, we get this. So this is what we need, like this, right? So we can see now ex equals to b times k equals to 0 to infinite, k to the power of 2 times p to the power of k minus 1. This equals to 1 minus p to the power of 2 times 1 plus p over 1 minus p to the power of 3. This equals to 1 plus p. This equals to 1 plus p over 1 minus p. So this is ex. Now let's see the problem C. In the problem C, we need to find ex to the power 2. So this equals to like k equals to 0 to infinite, k times, I'm sorry, it should be, let me think, k to the power of 2, yes, times probability, right? It should be b times k to the power of 3 times p to the k minus 1. So in this question, we need to figure out this one. And just like the method we used in the last question, we can still differentiate both sides of the equation, which is k equals to 1 to the infinite, k to the power of 2 times p to the power of k equals to p plus p to the power 2 over 1 minus p to the power 3. We can differentiate both sides of this equation, and then we get equals to 1 plus 4 times of p plus p to the power 2 over 1 minus p to the power 4. So this is what we need to find. Then we replace this with this, we get that this equals to 1 minus p to the power 2 times 1 plus 4 times of p plus p to the power 2 over 1 minus p to the power of 4. This equals to 1 plus, this equals to 1 plus 4 times of p plus p to the power 2 over 1 minus p to the power 2. That's it? Yes. Then let's see the problem number D. Problem number D. Let's see. Right. Problem number D. We need to find e x to the power 2 minus e x to the power 2. This should be easy because we already know e x to the power 2 and ex, so it's just a calculate, like 1 plus 4 times of p plus p to the power 2 over 1 minus p to the power of 2 minus, let's see, minus 1 plus p to the power 2 over 1 minus p to the power 2. So this equals to 1 minus p to the power of 2. The top side is 1 plus 4 times of p, plus p to the power of 2 minus 1 plus 2 times p plus p to the power 2. This just equals to, let's see, right, this equals to 2 times of p or 1 minus p to the power of 2. So this is problem number D. The last problem is problem number E. It says that P equals to 1 over 3. Find the conditional probability mass function, which is Px equals to k according to x larger than 2 and smaller than 5. We need to figure out this. X equals to k when x larger than 2 and smaller than 5. This is our purpose. And let's see how to solve this problem. First, we know that P equals to 1 over 3. Then we get b equals to 1 minus p to the power of 2, which equals to 4/9, right? Then in this probability, this one equals to this probability over this. This is the definition of the conditional probability function, and this equals to let me see, the top side still like this, and the bottom side should be kx to 2 to kx equals to 5, 4/9 times k times 1/3 to the power of k minus 1. Alright, and this equals to around this value. Where k equals to 2, 3 to 5. So this is the homework 3, problem 1. That's it. Thank you.